Hey guys, in this video we're going to talk about Chapter 3, Section 2, Quadratic Expressions. So let's do a little recap from last time. We talked about three different sorts of form for quadratic functions. We had standard form, ax squared plus bx plus c. If a was positive, we knew it opened up. If a was negative, it opened down. And c was the y-intercept. Vertex form, a times x minus h squared plus k. Again, if a is positive, it opens up. If a is negative, it opens down. And h comma k was the vertex, aka the minimum point, or if it opens downward, it's the maximum point. Finally, we talked about factored form, y equals a times x minus r times x minus s. Once again, if a is positive, it opens up, and if a is negative, the parabola opens down. We call r and s the zeros. These are also the x-intercepts, where the graph crosses the x-axis, as shown in this little picture here. So let's kind of use what we learned last time and answer these questions. So the first question says, what are the zeros of the quadratic function? G of x equals negative 2 times x plus 1 times x minus 3. Well, the first thing you should recognize is which form are we in? Are we in standard, vertex, or factored form? And it turns out we're in factored form here, right? Because this looks exactly like y equals a times x minus r times x minus s. Okay, and what the zeros are, remember the zeros were r and s, so we can see here that that s is going to be 3, right, and r is not going to be positive 1, it's actually going to be negative 1, because if we plug negative 1 into this general form, we are going to get this positive back, so it's kind of the opposite of what you think. So these are my zeros. That's where the graph is going to cross the x-axis. And, just a reminder, we can always confirm this suspicion with Desmos. So if we put this function in Desmos, negative 2x plus 1, x minus 3, and we click on the x-intercepts, or the zeros, we can indeed see that our first zero is at negative 1 and our second zero is at 3, just like we got here. What is the y-intercept of the function above? Well, we can check this with Desmos if we wanted to. If we click on the y-intercept where it crosses the y-axis, we can see that it's 6. Another way we can do this is we can plug in x equals 0, right? Because that's the definition of a y-intercept. That's where, when x is 0, what is y? So if we plug in x equals 0 into our function right here, we get 0 plus 1, 0 minus 3, and then we just evaluate this guy. So this is y. And we get negative 2 times 1 times negative 3, and that indeed is going to give us 6. So that is our y-intercept as confirmed with Desmos. Does it open up or down? Well, in this case, if we look at our function, a is negative 2, and so since it's negative, it opens down. Name 4 ordered pairs that the function passes through. So again, we can look at Desmos, or we can make a little t-chart. So this is x and this is y, which equals negative 2 times x plus 1 times x minus 3. So we're putting our x values in there. Now we already technically got a y value when x was 0. We got the pair 0, 6. Right, we plugged in 0 for x, we got that ordered pair. Another ordered pair, we could plug in x equals 1 and see what we get out for y. If we do that, we get negative 2 times 1 plus 1, just plugging in 1 for anywhere I see an x, times 1 minus 3, and that's going to give us, let's see, negative 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. Okay? We could plug in 2 and get negative 2 times, I'm plugging in 2 for x this time, times 2 minus 3. And I get negative 2 times 3 is negative 6. Negative 6 times negative 1 is a positive, negative 6 times negative 1 is a positive 6. Okay. And finally, if I do just the next x value that comes to mind, which is 3, and I plug in 3 anywhere I see an x, I get negative 2 times 3 plus 1 times 3 minus 3. And I can see this goes to 0, so 0 times anything is just 0. All right? And that coincides with one of our x-intercepts that we found. So my ordered pairs I have 0, 6. I have 1, 8. So just x, y's, remember that. 2, 6, and 3, 0. And we can verify this on Desmos by, by seeing if these points are actually on there. So like, for example, 2, 6, I can move that point around until I get there and I see, oh yeah, it does actually lie on the parabola. So that's, a way that you can check it with Desmos. All right, so does this function y equals 3x squared minus x plus 6 open up or down? Well, what form are we in? We are in standard form, right? This is the form ax squared plus bx plus c. And the value that tells us if it opens up or down is a. A here is 3, which is positive, which tells us it opens up. What is the y-intercept of the function? Well, the y-intercept occurs when x is 0, so I'm going to plug in 0 anywhere I see an x into my function up there. So I get y equals 3, and I'm plugging in 0 anywhere I see an x, and then I'm just going to evaluate. So this guy, 0 squared is 0, 3 times 0 is 0, minus 0 plus 6, I end up getting a y-intercept of 6. And I didn't really have to do that work. I could just note that this is in standard form, and this 6 is c, and c is the y-intercept. All right, so name 4 ordered pairs that the function passes through. So again, I can go on Desmos. I can also just do this by hand. My function y is 3x squared minus x plus 6, and I just found one of them. When x is 0, I found out that y was 6, as seen right here. I could make up some other points too. When x is 1, what is y going to be? Well, y is going to be 3 times 1 squared minus 1 plus 6. Anywhere I see an x in my function, I'm plugging in my input variable 1. And just evaluating. So this is going to give me 3 times 1 squared is going to be 3, right? 1 squared is 1. So we get 3 minus 1 plus 6, and that's going to equal 8. All right. So if I plug in 2 this time, I get 3. So I'm plugging in 2 for my input anywhere I see an x to get my output, which is y. And I end up getting, well, this is going to be 3 times 4. So that's 12 minus 2 is 10 plus 6 is 16. And I'll do one more. Let's do x equals 3. It doesn't matter which x you choose. Remember, you can choose it because it's the independent variable. I'm just picking I'm just picking the numbers in order, honestly, but you could pick any number you wanted to, really. So again, I'm just plugging in a 3 into my input. Anywhere I see an x, I'm going to replace with a 3. And this ends up being 3 times 9. 3 squared is 9, minus 3 plus 6. This is 27 minus 3 plus 6. So 24 and 6 make 30. So this is going to be 30. Alright, so I have my ordered pairs. Remember, my ordered pair is just my output, my y value, when I plug in my input into the function. So I have 0, 6, 1, 8, 2, 16, and 3, 30. And I do encourage you to verify this on Desmos, that these are actually on the graph. Alright, so let's look at this one. Does this function open up or down? Now, what form do we have here? Well, this is going to be vertex form, right? Because we have the a in the front, we have the h on the inside of the parentheses, and we have k at the end. So remember, again, a is going to be that number in front. It's negative. So this is a, and it's negative, so this is going to tell me it opens down. All right. What is the vertex? So the vertex is h comma k. All right, and so h is 4, we can see that, and k is that constant at the end, which is 1. So it's going to be 4 comma 1. This is h and k. All right, is the vertex a max or a min? A maximum or a minimum? Well, that depends if it opens up or down. Since it opens down, it's going to look like this, and our vertex is going to be up here. And so this is a maximum. This is the highest point on the graph. If it opened up like this, we would have a minimum, but it doesn't. What is the y-intercept of the function? Well, this time our input variable is t, so we're going to replace t with 0. So we say, well, g of t is going to be equal to negative 1/2 times t minus 4 squared plus 1. So anywhere I see my input variable, which is t, I'm going to replace with 0 to get my y-intercept. So I get negative 1/2 and then 0 minus 4 squared plus 1. And I'll go ahead and evaluate this. So PEMDAS, parentheses first, 0 minus 4 is negative 4. The next thing in PEMDAS is the exponent, PE, PEMDAS. So negative 4 squared is 16. So I'll do that. So this is negative 1/2 times positive, negative 4 squared is positive 16 plus 1. Next comes multiplication. Negative 1/2 times 16, or negative 16 divided by 2, if you like that, is negative 8. Plus 1 is going to give us a final answer of negative 7. So this is my y-intercept. Name 4 ordered pairs. Well, we just found one. This is, well, actually, we'll make this t, since that's our variable acting like x. And then g of t was negative 1/2 t minus 4 squared plus 1. So we just found one ordered pair. When t was 0, we found out that our output was negative 7. If I plug in 1 for t, I get negative 1/2 times 1 minus 4 squared plus 1, just plugging in 1 for my variable there. And I get, this is going to be negative 3. Negative 3 squared is positive 9. So I have negative 1/2 times positive 9 plus 1. And I'm just going to put this in the calculator. And this is going to give me negative 3.5, or if you want to write as a fraction, that's cool too. For 2, I'm just plugging in 2 in for t. So this time I have negative 1/2, 2 minus 4 squared plus 1. I'm just going to put this in the calculator again. Yeah, and this is going to give me negative 1, I believe. Okay. And finally, we'll do 3. So I'm plugging in 3 for t. Okay, and I get 0.5 or 1/2. All right, so my ordered pairs here. I got my inputs on the left, I have my outputs on the right. So my ordered pairs. We have 0, negative 7, 1, negative 3.5, 2, negative 1, and 3, 0.5. Okay, the figure shows the graph of a quadratic function. If the function is in standard form, y equals ax squared plus bx plus c, is a positive or negative, and what is c? So first of all, with a, we can see from this picture that it's opening down, and so this means that a is negative. We know that about a. Now c is the y-intercept. It's where it crosses the y-axis. So that's going to be this point right here. And this is 1, 2, 3. So this is going to be the point x is 0, y is 3. And so the y-intercept is 3 or 0, 3 if you like that. This is the y-intercept. Okay, so that was part A. We got that. So if the function is in factored form, y equals a times x minus r times x minus s with r less than or equal to s. What is r and what is s? So r and s are the zeros. That's where it crosses the x-axis. So we can see that it crosses right here, and it also crosses right here. And this guy to the right is going to have an x value of 1, 2, 3, a y value of 0, right? So this is a 0, or an x-intercept. And the other one is going to be negative 1, 0. This is another 0. So therefore, my first 0, r, is going to be negative 1, the smaller one. And s is going to be 3. These are my x-intercepts. And the last question says, if the function is in vertex form, what is h and what is k? So the vertex is going to be the highest or lowest point. Actually, I'm going to make some room here. So this is the, right here, this is the y-intercept. And the vertex is going to be this very highest point, which we can see right here. And so this has an ordered pair of x equals 1, y equals 1, 2, 3, 4. This is h, k. So h is going to be our x component of the vertex, which is 1, and k is going to be the y component, which is 4. So that's going to be the highest or lowest point. In this case, it's a highest point because it opens down. All right, match the graph to one of the equations, and we have some options here. So let's just go option through option and see, if it works. So we can see, first of all, that these are all in vertex form, right? These are all in vertex form. A times x plus h, or x minus h squared plus k. So the question is, do any of these match? Well, let's look at choice A first. This is saying that my vertex, my h is negative 3. Remember, it's the opposite of what you think for h. And my k is positive 1, so my vertex here should be at negative 3, positive 1, but we see that that's not the case. The vertex right here is at positive 3, negative 1. So choice A is incorrect. Choice B, this is saying that the vertex is at positive 3, positive 1, but again, we need the k to be negative 1. So this is incorrect as well. C is automatically incorrect because of this negative sign. That would say that the parabola is opening down that way, but it's not. It's opening up, so that can't be it either. And this guy, h is negative 3 and k is negative 1, so k is negative 1. So that's also not right because h is positive 3 and k is negative 1. So that's not right either. So the correct answer here is there is no match. That is our answer here. All right, let's do this one. So I encourage you to pause the video and see if you can do this one. So match the graph to one of the equations. First of all, these are all in vertex form, which means that a good thing to get is the vertex. So the vertex is the highest point in this case, and that's going to be at x equals 2 and y also equals 2. Right? So that's our vertex. So that's our h comma k. And we can see from this first equation that h is negative 2, right? It's opposite of what you think for h, and k is positive 2. And this doesn't match. They need to both be positive 2, so that's not it. If we look at choice B, h is positive 2, and k is also positive 2. So that looks promising. However, this is positive. This A is positive, and so this is saying it's going to open up. So that's not correct. If we look at choice C, this time H is positive 2 and K is positive 2, and this negative sign says it opens down. So that's the correct answer. All right, so choice C is our answer here. Find a possible formula for the quadratic function whose graph has a vertex of 1, 2, and a y-intercept of negative 6. So if we're given a vertex, chances are we're going to use vertex form to answer this question. So let's write out our vertex form right here. And so we're given two clues. We're given the vertex, we're given the y-intercept, and we want to write the formula. So we want to get numbers for A, H, and K. Now, H and K were already given because since they say the vertex is 1, 2, that means that H is 1 and K is 2. So we already have that piece. All we need to know is what is A. And we can figure that out from the second clue. So it says the y-intercept is negative 6. And this is kind of like what we did with linear functions when I gave you a point and a slope and I asked you to find b. This is the same kind of principle here. So the idea is to use a point that we know that's on the graph. In this case, the point is x is 0 and y is negative 6. Because by definition, a y-intercept has to have x equals 0. That's the point. So we know x, we know y, we're trying to find a, we know h, and we know k. H is going to be 1, and k is going to be 2. And our question is, what is a? So just like with slope-intercept form, we're plugging in all of these values into our base formula here. So we start out with y equals a times x minus h squared plus k. And I'm going to plug in all of these values that I have here. So y is negative 6, so we replace that there. We're trying to find a, we don't know it. We're replacing x with 0, we're replacing h with 1, and we're replacing k with 2, and then we're just solving for a. So on the left side, I can't really do anything. On the right side, -1 squared is +1. So this becomes a times 1 plus 2. And of course, a times 1 is simply a. So this is a plus 2 equals -6. And I'm going to go ahead and subtract 2 from both sides to give me a by itself. So I get a on the right by itself equals -6 minus 2 is -8. So my formula is going to be y equals a, which is -8, times x minus h, which is 1, squared, plus k. Remember, when they're asking you to write a formula, x and y need to stay as x and y, because the point of the formula is for you to choose any x, punch it in, and get out a y value. So that's our answer there. We found a, and we knew what h and k was by the, from the directions. Let's do another example. So I'd like you guys to pause the video and try this one out on your own. So again, we're trying to find a formula for a quadratic, and since we're given a vertex, chances are vertex form is going to be the most helpful thing here. Now again, they tell us the y-intercept is 2, and that means when x is 0, y is 2. That's the definition of that. So again, our vertex form is y equals a times x minus h squared plus k. And what I'm going to do is I'm going to plug in all of my values and solve for a, just like I did before. So remember, h is equal to -3. We can see that here. K is equal to 6. X is equal to 0, and y is equal to 2. That's the ordered pair that we're given. If we were given another point, such as 2, 3, we would use x equals 2, y equals 3. But we're given the y-intercept, so we know x has to equal 0. All right, now that that's out of the way, we'll plug in all of our values. So y is 2. We don't know a. X is 0, minus h, minus a -3, squared, plus k. All right, now check this out. These two negatives make a positive. So I get a 0 plus 3 squared plus 6. And 0 plus 3, of course, is 3. 3 squared is 9. All right, so I want to get a by itself, so I'll first undo addition of 6 by subtracting 6 from both sides. And I get -4 on the left equals a times 9 on the right. My last step is to divide both sides by 9 to get a alone. And I do get a value for a here. I get a is equal to -4 over 9. So my final answer, my formula, is going to be the vertex form, but only replacing a, h, and k. So I have y equals, well, I just found a. It's -4 over 9. Times x minus h. Well, the double minuses become a plus. Plus k. So this is my answer here. All right, plot the graph of the function using the vertex, y-intercept, and 2 additional points. So, first thing I'm going to do is plot my vertex. This is in vertex form because I have y equals x minus 3 squared, and I secretly have a plus 0 at the end. And so h comma k is going to equal 3 comma 0. So that's my vertex. All right, we can see that here. So let's plot the vertex first at x equals 3, y equals 0, so that's going to be right here. And then we're going to go ahead and find the y-intercept, and then we'll find the other points. So the y-intercept happens when x is 0. So I'm just going to take this function and plug in 0 where I see an x and solve, or evaluate rather. So our y-intercept turns out to be -3 squared, which is 9. So when x is equal to 0, y equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we go. So that's my y-intercept. This is my, maybe I'll write this here, this is my vertex. Okay, now I want to plot 2 other points, and I can do the trick that I did in the last video, or you can just pick points by hand if you want. I'm going to make a little t-chart right here, and I have x and I have y. And so what I'm going to do is I'm going to choose an x to the left of the vertex just because it looks, you know, it's an easy point to work with. So I'm going to choose x equals 2. And when I plug in 2 for x into the function to get y, I get 2 minus 3 squared, which is -1 squared, which is +1. So when x is 2, y is 1. So when x is 2, y is 1. So that's my first additional point. Now keep in mind from the last video that a line of symmetry goes through the vertex. And so we can be a little bit lazy if we don't want to like plug in stuff. You know, we could plug in another point and get one out, but I'd rather just be lazy. What we can see here from the line of symmetry is that this point that we just found is 1 away from the line of symmetry. And since the line of symmetry is going to cut this thing in half, I know that this point also exists on the parabola to the right. And so I can just connect these dots right here. I can connect all of them. It goes through the y-intercept as well, and just kind of make a little picture like that. So there is my graph. All right, let's try another one. So we want to plot the graph of y equals -x minus 2 squared minus 2 using the vertex, the y-intercept, and 2 additional points. So first thing I'm going to do is figure out what the vertex is. Now I am in vertex form. So the vertex, I can see that h is going to be 2 and k is going to be -2. So I can plot that out. When x is 2, y is -2. So there's my vertex. I can also figure out what the y-intercept is because when x is 0, I get a y-intercept. So for my y-intercept, I'm just plugging in 0 for x into my function. So this is going to be again, I just plugged in 0 to figure out what this y value is. So simplifying the inside, 0 minus 2 is -2. PEMDAS says I need to square this first. -2 squared is +4, so I have a -4 because of this negative, it's staying out there. -2, -4 minus 2 is -6. So this is my y-intercept. -6. So when x is 0, y is -6. This is my y-intercept. Again, my vertex was 2, -2. And now I can figure out some other points by using a little table. So I have my input and my output is negative x minus 2 squared minus 2. So if I look at my vertex, directly to the left of my vertex, or you could look to the right, it doesn't matter, but directly to the left is x equals 1, right? To the left of x equals 2 is x equals 1. So I'm going to see what the y value is when x equals 1. If I plug in 1 anywhere I see an x into my function, I get negative, and then in parentheses, 1 minus 2 squared minus 2. And this is going to give me, let's see, negative 1 minus 2 gives me negative 3. So one of my points is 1, negative 3. And so I can just put that right there. Now again, I can use my trick with the line of symmetry that goes through the vertex. So since I already found this point right here, I can simply reflect it over on the opposite side of the vertex to get another point. And so I can connect the dots at this point and get a nice little parabola. Alright, so this is the last one we're going to do here. For the function negative 2 times x plus 1 squared minus 3, find the max or min and sketch the graph using the vertex and 2 additional points. So we don't have to find the y-intercept here. We can just find the vertex and do our little reflecting trick. So first of all, right off the bat, I'm looking at this function and I'm seeing that there's a negative in front of the 2. And that tells me that it's going to look like this, which means it's going to have a max. So right off the bat, I know that there's a maximum. Let's go ahead and sketch the vertex. So we're given the function negative 2 x plus 1 squared minus 3. And the vertex is going to be h comma k, but again, this 1, remember it's the opposite of what you think. The vertex is actually going to be at not 1 comma negative 3, but it's actually going to be at negative 1 comma negative 3. It's always opposite of what you think. So let's go ahead and plot that. When x is equal to negative 1, y is equal to negative 3. 1, 2, 3. There's a negative 3. So there's my vertex. I'll do it in green. And then I want to get 2 other points. So I'm actually going to use the y-intercept because it's directly to the right of negative 1. X equals 0 is to the right. So I'm going to go ahead and do a little t-chart, and I'm going to start with x equals 0 to see what I get for my output here. So I'm plugging in x equals 0 in for x into the function right here. And I get, let's see, 0 plus 1 squared is 1. 1 times negative 2 is negative 2 minus 3 is negative 5. So I get an ordered pair of 0, negative 5. So when x is 0, y is negative 5. Right there. So that's what that looks like. Now my line of symmetry, I'm going to use the trick here. And I'm simply going to, since this guy is 1 away from the line, I'm also going to have a point 1 away in that direction. And then I'll just connect the dots like that. And there's my picture. So what's the max? Well, the max is going to be the vertex. And your homework is going to show you this notation, but it's just basically asking for h and k. This is h and this is k because this is the input and this is the output. So in our case, our input, our x coordinate is negative 1. So when x is negative 1, our output is negative 3. So that is the maximum because it's the vertex of that graph.